So, let's start. So I'm going to just try and read a bit more than anything else. I got through most of this chapter, and then maybe I'll do some proofs. Okay. In this section, we define how to substitute a term t for a variable in a formula at all the places where substitute a term t for a variable. So replacing t with the variable or replacing a variable with t. Oh, at all the places where x occurs free, thus obtaining a formula, so it's the variable. We wish to define the substitution so that psi expresses and psi's formula the same thing about t as phi does about t. So the first example here is that let's say we have a formula phi and we decided to replace this number right here, or this variable, with z also being a term as well. Then you get one that doesn't make sense because you end up with there exists z where z plus z equals z, which is always fulfilled by 0 plus 0 is equal to 0, therefore it's always true. Whereas here, if you say there exists c plus z, which is equal to x for the natural numbers, and just integers too, this is just whether it's even or not. So it's about whether you bound it or not. On the other hand, we obtain a formula which expresses the same thing about z as phi expresses about x. If we proceed as follows, we introduce a new bound variable u, and replace z with u, or x with z, and then it's fine. Cool. So we go through some definitions about substitution stuff, where we say in the preceding example we replaced only one variable, but in reality we care about doing multiple ones. So given a formula phi and distinct pairwise variables x through xr and arbitrary terms t through tr, we associate a formula phi with this symbol over here, which is said to be obtained by simultaneous substitution of t or whatever or x, not through xr. Xi is only replaced if xi is free, of course, inside of the system. So then there's a couple of definitions about this. This is a little bit weird, how they read to me, at least. So defines it for terms, then it defines it for formulas, and the definition for terms. So if x gets replaced by t through t0, goes to x through xr, it's equal to x if x is not in the variable set, and it becomes ti if x is equal to ti. So that's a little bit weird because I thought we were replacing t naught with x naught down here, not the other way around. Of course, constants you have nothing with because they're constants, but this is a variable. Is it a variable or is it a term? It's just a variable, I think. We have to go back to proof by induction here. If I recall correctly, where is definition? Every variable and every constant and every term. It's a little bit different though. This is the proof by that, not the definition. The definition is basically the same thing. Okay, whatever. So well, let me skip ahead to see if it helps me out understanding this a bit more. Really wish my camera would be up top instead. Maybe I'll buy something to do that. It'd be cool. So if we have a function of a bunch of terms, you do the function, but you replace the terms, you substitute the x naughts in the terms for you substitute the subterms in the terms for the x naught through xr, which still a bit odd because with x, where x is a variable, you're defining it as equaling x if it's not inside of the terms to be replaced, that you're replacing it with one of the terms if it's, and that doesn't make sense to me. Like, why would you be replacing it with ti here? Like, isn't that doing exactly the opposite of what we're... I guess not. I guess I'm just misreading. Yeah, because you're replacing the terms with variables, not the other way around. No, you're replacing the variables with terms. So you don't do any... Okay, that makes sense. So you replace it if it's in the x naught through xr. You don't replace it. If you do replace it, you replace it with ti if there's a corresponding x naught that x is equal to, and you don't replace it if there's no xi to replace it with. Silly. And I forgot. There we go. Boom, better. Okay, so we're replacing terms with variables for some reason. Then you have definitions by, you have the definitions for formulas as well, which you're basically just replacing all of the subterms in the formula with it. Just like duh. We have the last one here. We have to deal with existence and quantification. So you have xi through xis. Such that x is free. It's a free variable. xi are the set of exactly the set of free variables. Suppose xi1 through xis are exactly the variables xi among, so it's like a subset of x0 through xr, such that all these variables xi are free within there exists a quantified formula. Then well, x is not by, I mean, yeah, sure, the sentence is trivially true, I think. I mean, it seems like it. Okay, then we do an existence type thing here, where if we're replacing terms by variables, we define there exists a u, and we replace inside of we do the replacement inside of the variable, and we also replace u with x, or x with u. What? We're substituting t0 through tr for x, so we're substituting terms for variables. We're substituting terms for variables, and for some reason we're substituting u for x inside of here, where u is the variable x. If x does not occur inside of the other terms that are being replaced. Otherwise, u is the first term in the list, which does not occur. By introducing the variable u, we assure that no variable in Ti falls within the scope of a quantifier. In their case, there's no x. In case there is no xi, that is within the free variables, and xi does not equal ti. So I guess I'll just see how this works. So binary p and f, we have this relation here. And it basically replaces 0 doesn't change here. It's not down here. 1 changes to 2. Bingo. 2 changes to 0. Okay, so then there exists. There exists V naught. Then you have the same formula. And so what happens if you replace V0 with V naught? Then you get there exists V naught. So why is there then a U? Oh, okay. So the first thing you do is you pull out V naught from the formula. You say, no, don't touch this. And then you do the rest of the replacements that you would normally do. Except you have it, so V naught gets replaced with V naught. Oh, I see. So you're just replacing the existential quantifier with just an arbitrary, the quantifier with a arbitrary number, or the arbitrary variable. Okay. Which makes sense. Yeah, and this one does the same thing where you, yeah, okay. All the places where xi occurred free and phi, we find now term t, that the term ti. Yep. If the free is a subset of x naught, blah, 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 then we expect that ti will hold for an interpretation if and only if phi holds in A, provided we use the assignments T naught for XR. So the free variables are a subset of the variables to be replaced into. Yeah. If it's a subset of the terms that we expect it to change into, changes quite a bit. The free variables of phi are a subset of x naught through xr. We expect that replacing the terms with x naught through xr will hold for an interpretation j ab if and only if phi holds in A, provided we use the assignments for the terms. We use the assignments j, ti, t naught for x naught through jtr for xr. Okay, it says they do it in 8.3. So substituting variables for constants. Let's just yeah. Okay. So this just generalizes up here substitution to multivariables. Well, I'm going to read through the substitution lemma because I have poo brain syndrome. For every term t such that the interpretation of t where x naught through xr are replaced with t naught through tr is equivalent to the substitution of x naught through xr. Oh, this makes a lot more sense. Where you're replacing t naught with its interpretation up here applied to t. Yeah, because we're using this right here. Silly. T is equal to x, and x is not within x naught through xr. Then by definition, 8.1a, just the start of the proof. So we do induction on terms. So if it's a variable, so this says that for every term t, if we replace the variables x through xr with the terms t through tr, it's okay. The values of the terms stay the same and the values of the formula stay the same. Okay, so the first one is A, of course. X is not in the variables. They're being replaced. (8.1a) x on this right here is equal to x, since nothing's being replaced there. Which is equivalent to replacing all the terms with x. Yeah. Yeah, I mean, I guess. I'm gonna phrase it that way, sure. Because you're using this right here, this right there. I bought a camera holder thing so I can move this up there. Just because I got annoyed. Okay, so if x is within the variables being replaced, it becomes ti, and then j on x replaced by ti is equal to j at ti, which is once again equivalent to the j interpretation type thing. Yeah. Yeah. Do we have to do this for functions as well? Am I missing something here? No, you don't, because you don't need induction on the first part. So this is like one of the things about mathematics that's interesting to me. A lot of it, it's not as horrifyingly complicated as people like to make it out to be. But there's definitely a language associated with it, and you have to know that language, and you have to understand it. You have to be able to speak it in order to really understand what's going on when people talk about silly stuff. And this is one of those sad things. Like, I want to be able to build up the model theory, but there's stupid things where it's like I have to know the language being used, which is such a pain to figure out. It's like, this is how I I remember when I was trying to build up the gauge theory, I had to go through like all this topology stuff, and I had to deal with topology of point set topology. Then I had to deal with, there's this whole entire series of books. It was like point set topology. Then it was topology on some sort of manifold, and then topology on normal manifolds. There were like 3 in a row. Can't remember what the last 2 were. I don't think they were Riemannian. Or maybe it was just topology, manifolds, and then Riemannian manifolds. I think that was it. Yeah. I'd go through a lot in all 3 of those books just to get up to the fucking book I wanted to read on gauge theory. Which turned out to be more lame than I expected, which sucks, but whatever. I mean, it's useful, but... Okay, so if your formula is a relation... So your model satisfies the formula if and only if. This is so intuitively true. If and only if your model, where you replace x with t naught and xr with t naught, still fills the model. Yeah. So as phi is a formula that's a relation, J is satisfied when you wait. Phi is a relation phi is a relation between t and tn. So J satisfies the substitution if and only if. Yeah, so this is the left half here, and these are the right halves. Okay. If JR holds for what? So does that just map to a function? That's not a function. Does that just map to the set? Guess I'm forgetting what this is right here. I think I know what it is, but I'm not sure. Oh, I'm misinterpreting it. Where J is an interpretation. What do they mean by JR here? Like, it doesn't make sense. You can't have that hold. Okay, so interpretation is a pair. And but it's not a map, it's just a is it a map? So I understand the idea of a structure. A structure basically maps symbols to relations, functions, and constants. Variables are mapped to A based on an assignment, but an S interpretation is just a pair of both a structure and an assignment. It's the pair of a structure and an assignment. Am I misreading this? Because you could say that, like, the interpretation acts as a map itself. I'm missing something here. Oh, here we go. Okay. That makes sense. So it does act as a map. Yeah. Duh. But it's a function on terms. I guess R isn't a function. Is this like a misprint? Do you mean to type out the whole entire thing? Because you can't just take R. Or at least if I'm understanding it properly. Because J is defined on terms. R is not a term. A term is defined by where's the simplified version of it? Oh, it's going to be up here, of course. Whoops. Yeah, so You have x, you have c, and then you have functions of x and c. R is not a term. So what am I misinterpreting here? If J of R holds for that, and I assume it's similar for no. J is an interpretation. You can apply interpretations to terms. Not formulas. The fuck? Okay, so if I read the right-hand side, what makes this make most sense? Because I'm guessing this is a mistype. Um, I've had this issue in these series of books before where like occasionally the author mistypes something up and then nobody ever corrects it. So maybe this is the same thing, but like, I don't know, I do it in 3 separate places here. Phi is equal to maybe it's a copy paste error. That's why you see it multiple times. I mean, that could be easily the case with latex. Okay, by 8.2b. 8.2b says that if you have a relation, you perform a substitution on the relation, you perform the substitution on all the subconstituents of it. Okay. So Wait, what? I'm really missing something here. So the requirement of the proof is to show that the interpretation holds on the substitution of variables for terms if and only if the interpretation where the variables are substituted for the interpretation of the term satisfies the original formula. So if we want to prove it, what we have to show is that the interpretation holds under the substitution, the formula substitution, if and only if the interpretation substitution holds. So yeah, I'm missing something obvious here. Wait. J of R we're just going to post it on Twitter, see if anybody responds. Is this often like one of those things where like I can tell it's not that complicated, but it's like annoying? Your brain farts and decides, nah, I'm not going to do it. Hey, Modi. Hi, buddy. Hey, puppy. You're a good dog. Who's your good boy? Come here. You want to go out, don't you? You want to go on a walk, don't you? I say no. Come here. Instead of going on a walk, you're going to be on the stream. Is your tail wagging? Is your tail wagging? Yes, I see you. What? Okay, so let's try and keep on going through just to get to the end of this chapter. And then I'll probably read one section of Thus Spoke Zarathustra. So if you permute the numbers then it remains the same. The zero is less than I is less than R, and xi is equal to t. Then yes, Modi, I see you. So I know you want to go out. It's not 5 o'clock yet, though. Not time. We'll go out in a bit, just not yet. In phi, where you're substituting x in for the terms, is equivalent to if you insert a term in, wait, no, that's not what it's saying. It's saying, Modi, stop it. Oh, if you remove, yeah, if xi is equal to ti, what? If the variable is equal to a term already, I mean, then you don't, then substituting it's meaningless. Yeah, okay. I'd write that ti is equal to xi, but, you know, whatever floats your boat. Then it says for every variable y, if y is within the variables after a substitution inside of the terms, then y is within any of the individual terms, or y is within the var of t, because, yeah, because he didn't do any of the substitution. I need to know more proofs, which I'll do in a bit, but I'm going to read Nietzsche right now. I read the Tarantulas, which it's a very straightforward one. Terrifying, though. I'm going to read on the famous wise men. The people you have served and the people's superstition, all you famous wise men, and not the truth, and precisely on that account you were accorded respect. And for this reason they too tolerated your lack of faith, because it was a joke and a jog to the people. Thus does the master allow his slaves to have their way, delighting all the while in their frolicking. So is he talking about like modern philosophers, I guess? Like Hume, for example. But whoever is despised by the people like a wolf by dogs, this is the free spirit, the foe of fetters, the non-adorer, the one who houses in the woods. Hunting him out of his lair, to the people this is always meant a sense of what is right. On him the people have always sicked their dogs with the sharpest teeth. For the truth is here, if only the people are here. Woe, woe to the seekers. Thus it is echoed for all time. You wanted to justify your people's reverence. That is what you called will to truth, you famous wise men. And your heart has always said to itself, from the people I came, there too God's voice came to me. As advocates of the people, you were always stiff-necked and clever like asses. And many a powerful one who wanted to travel well with the people harnessed a little ass in front of horses. Many a powerful one who wanted to travel well with the people harnessed a little ass in front of his horses. A famous wise man. Yeah. And now you famous wise man, I wish you would finally throw off the lion's skin completely. The mottled skin of the predator, the mane of the explorer, the searcher, the conqueror. Oh, before I would learn to believe in your truthfulness, you would first have to break your revering will. Truthful, thus I call the one who goes into godless deserts and has broken in his revering heart. And has broken his revering heart. And my webcam is dead. As always. I'll keep on reading. And replace it at some point. In the yellow sand and burned by the sun, may he squint thirstily at islands rich with springs, where living things rest beneath dark trees. But his thirst does not persuade him to become the same as these comfortable ones, for where there are oases, there are idols as well. Hungry, violent, lonely, godless, thus the lion will wants itself. Free from the happiness of the servant, redeemed of gods and adorations, fearless and fearsome, great and lonely. Thus is the will of the truthful. In the desert the truthful have always dwelled, the free spirits as rulers of the desert. But in cities dwell the well-fed, famous wise men, the draft animals. For they, as asses, always pull the people's cart. Not that I am angry with them for it. Couldn't this whole entire critique apply to Nietzsche himself too? It seems a bit... Not that I am angry with them for it, but to me they remain servants and harnessed, even if they gleam in their golden harnesses. And often they were good servants and praiseworthy, for virtue speaks thus. If you must serve, then seek the one who benefits most from your service. If spirit and virtue of your master shall grow from your being his servant, thus you grow yourself with his spirit and virtue. And truly, you famous wise men, you servants of the people, yourselves grew with the people's spirit and virtue, the people through you. I say this in your honor. But to me you remain the people, even in your virtues, the people with stupid eyes, the people who don't know what spirit is. Spirit is life that cuts into life by its own agony, increases its own knowledge. Did you know that? And the spirit and the happiness of spirit is this, to be anointed and consecrated by tears to serve as a sacrificial animal. Did you know that? And the blindness of the blind and his seeking and probing shall yet testify to the power of the sun into which he gazed. Did you know that? And the seeker of knowledge shall learn to build with mountains. It means little that the spirit moves mountains. Did you know that? You know only the spark of the spirit, but you do not see the anvil that it is, nor the cruelty of its hammer. Indeed, you do not know the pride of the spirit, but even less would you be able to bear the spirit's modesty, if it ever wanted you to speak. And never yet You have been permitted to throw your spirit into a pit of snow. You are not hot enough for that. And so you do not know the thrills of its coldness. But in all things you act too familiar. You act too familiarly with the spirit. Familiarity with the spirit, and wisdom you often make into a poorhouse and a hospital for bad poets. You are no eagles, thus you have not experienced the happiness in the terror of the spirit, and whoever is not a bird should not build nests over abysses. To me you are lukewarm, but every deep knowledge flows cold. Ice cold are the innermost wells of the spirit, invigorating for hot hands and human doers. Honorable you stand there, and stiff with the ramrod backs, you famous wise men. You are not driven by strong wind and will. Have you never seen a sail go over the sea, rounded and billowed and trembling with the vehemence of the wind? Like the sail, trembling with the vehemence of spirit, my wisdom goes over the sea, my wild wisdom. But you servants of the people, you wise men, how could you go with me? Thus spoke Zarathustra.